Section 2.2, to determine trig values of non-acute angles. In our first section of Chapter 2, we discussed trig values in relation to acute angles. But if you take a look at our first slide, we have three coordinate planes that have angles that are greater than 90 degrees. In other words, they're not acute. But so far, we've determined that our functions work with only acute angles. Well, how can we get the idea of acute angles when we are using angles greater than 90 degrees? Well, the definition we use is reference angles. A reference angle for an acute angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. So let's take a look at these three coordinate planes. In the first one, we have a initial side on the x-axis, and we have a terminal side that's going to end up in quadrant 2. The idea of a reference angle is actually taking a look at the terminal side in relationship to the x-axis, but between quadrant 2 and quadrant 3. The next one, again, we have an initial angle inside of the x-axis, and when we move that counterclockwise, it will end up in quadrant 3. Again, this is not acute, but the idea we want to use for a reference angle is the terminal side that's in quadrant 3 in relationship to the x-axis between 2 and 3. And the next one is almost a complete revolution. It's going to end up in quadrant 4. Again, we have an initial side on the x-axis, and our reference angle is from the terminal side of that angle in relation to the x-axis, and this x-axis will be between quadrant 1 and quadrant 4. Our next slide is an example for determining a reference angle. We want to find the reference angle for each angle. In this situation, we have 218 degrees. Well, our job is to find a positive angle made by the terminal side of the angle, which is at 218 degrees, and the x-axis. Therefore, our procedure to do this is to take 218, subtract from 180, that leaves us 38 degrees. Let's take a look at a diagram that represents this. As we can see, here's our 218 degree angle having an initial side on our x-axis sweeping into the third quadrant, and then we would actually have an angle theta here that is a reference angle for 218 degrees, 38 degrees. Our next example to find a reference angle is 1,387 degrees. It gives us a hint here. What we want to do is find a coterminal angle. And remember, a coterminal angle is an angle that represents 1387, but that angle would have to be between 0 and 360. So what we would have to do is remove a certain number of revolutions from 1,387 to get our degree in between 0 degrees and 360 degrees. Well, let's take a look at this procedure. First of all, we take 1,387 and divide it by 360. That will give us a quotient of about 3.9 degrees. So if we take 3 revolutions, which is 3 times 360, and subtract that from 1,387, we actually get a coterminal angle of 307 degrees. That will be in quadrant 4. So I know I'm going to have a reference angle in quadrant 4 with my terminal side of the angle in quadrant 4 in relation to the x-axis between 1 and 4. So when we follow this procedure, the reference angle for 307 is 360 minus 307, which gives me 53 degrees. And here is a diagram of this example. We know 1387 is going to give us almost 4 revolutions. But when I find the coterminal angle, it eventually will end up from the initial side of that x-axis to that position in quadrant 4. But my reference angle is going to be from my x-axis to the terminal side, and that will be 53 degrees. Our next slide gives us rules for actually finding reference angles in different quadrants. We're given quadrant 2, quadrant 3, and quadrant 4. There are no rules for quadrant 1 because the angles in quadrant 1 are already acute, which is what we want. So let's take a look at quadrant 2. If I have an angle in quadrant 2, then all I need to do is take 180 degrees minus theta, which is our given angle, and that gives us our reference angle, which they call theta prime. A quick example, an initial angle on my x-axis, counterclockwise revolution into quadrant 2. Let's call this theta equal to 150 degrees. Then my reference angle is 180 degrees minus 150, which gives me 30 degrees. In quadrant 3, it tells us that we have our reference angle theta prime equal to the given angle theta minus 180, because what we want to have is a positive reference angle. Let's take a look at an example. In this situation, again, I have my initial side of my angle on the x-axis, counterclockwise revolution into quadrant 3. And I'll just call that an angle theta of, let's say, 200 degrees. Then my reference angle would be 200 minus 180, or 20 degrees. My last example in quadrant 4 is going to give us a reference angle of theta prime equal to 360 minus theta. A quick example of that would be an initial side of my angle on the x-axis, counterclockwise revolution into quadrant 4. And let's say my theta is equal to 300 degrees. Then my theta prime would be 360 minus 300, which would give me a reference angle of 60 degrees. Our next slide combines our previous section, which is quadrant angles, 30, 60, and 45 degrees, with our new lesson here, which are reference angles. So what they want to do is find the value of trig functions for 210 degrees. Our previous section was finding these values for either a 30, 60, or 45 degree angle. Well, that means we need an acute angle, and we hope it turns out to be either 30, 60, or 45. Given a 210 degree angle, I can find the reference angle to be 210 minus 180, which gives me 30. Remember, on the previous side was anything in quadrant 2 was going to be theta minus 180, and that's exactly what we performed, was 30 degrees. Then it gave us a little bit more information. They said they're going to choose a point on the terminal side. They're going to call it P. And that point is going to be 2 units from the origin. So if I just draw up this diagram below, I see that my point P is on the terminal side, and the distance from the origin to point P is going to be 2. Now, they gave us all the other values, but I want to show you how this is determined. For example, if I use this triangle, which is a 30, 60, 90, because 30 degrees is my reference angle for 210, then I know I can drop a vertical, which will give me a 90 degree angle, and knowing that the 3 angles of a triangle add to 180, that leaves me 60 degrees. And also recall that if I am given a hypotenuse, I can find my short leg, which is opposite my smallest acute angle, which here it will be called y. And once I know my short leg, I can find x, which here will be my long leg, which is opposite my biggest acute angle. And recall we do that by taking my hypotenuse, which is 2, and dividing by 2, which gives me 1. But remember that our angle is in quadrant 3. So my short leg, which is y, is in quadrant 3, which makes y a -1. Now I can find my long leg. My long leg is equal to my short leg times the square root of 3. So my long leg is the negative square root of 3. Let's use the next slide to finish this problem up. On the previous slide, we found that my x value is a negative square root of 3. My y value is a -1, as shown here. We also were given that my r value is 2. Then I just need to substitute into my 6 functions to find the value for 210 degrees with a reference angle of 30 degrees. So recall here that sine is y over r. So I just substitute in y, -1, r of 2. Cosine is x over r. X is a negative square root of 3 over r2. Tangent is y over x. In this situation, y is going to equal a negative 1, and my x is a negative square root of 3. But I'm not allowed to have a radical in the denominator, so I need to rationalize, which multiplying the top and bottom by the square root of 3, which gives me a negative divided by a negative is a positive, and that would give me the square root of 3 over the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. And that's what we have shown here. Below, all we're going to do is take a look at the reciprocal functions of the original ones. So sine of 210, the reciprocal is cosecant of 210. That's the reciprocal of a negative 1 over 2, which is a negative 2. Cosine of 210, its reciprocal is the secant of 210, which is going to give me a negative 2 over the square root of 3. And when I rationalize, that gives me a negative 2 times the square root of 3, which is here, and the square root of 3 times the square root of 3, which is 3. And tangent, its reciprocal is cotangent, which is going to give me 3 over the square root of 3. And when I multiply, that's going to give me the square root of 3 over the square root of 3, which gives me 3 square roots of 3 over 3, which equals the square root of 3, which is given here. We could have taken this into a lot quicker version, but just find the reciprocal of this value, which is 1 over the square root of 3. Its reciprocal is the square root of 3.